Welcome to Chapter 2 in SGD 213, Programming 2. In this chapter, we're going to be going over a new game genre in which we're going to be making a physics puzzler. So I'm just going to go ahead and reveal the game we're going to be making. It's going to be a breakout game. Let me just maximize this. We're going to be making Breakout. I don't know if you guys have ever seen a game like this before, but, sort of a puzzle game in which you use the paddle ball to destroy bricks up top. We have a few things going on right now. We have a live system that tracks how many tries you get. We have a ball that collides with bricks. We have particle systems that are instantiated when a brick is destroyed. Right? We don't have a brick counter or a score because success is measured whenever you destroy all the bricks. All right. Let's see. Maybe that'll hit it. And we have a few things going on whenever you win. Oh, missed it. Boom. We slow down time and we display a you win. And the game reloads. Alternatively, if we lose 3 times without destroying all the bricks, we get a game over screen and the game reloads itself. We're going to be looking at how we can add some physics to the game to get the ball to bounce off of objects and the paddle. We're going to be looking at how we can use rigid bodies to add force to our ball to get it moving in the first place. We're going to be reviewing math clamp so we can keep our paddle within our play bounds. And we're going to take a look at the new Singleton Pattern for creating a nice game manager that holds global variables and global functions to help maybe optimize the way our game is coded and designed. And lastly, we're going to be looking at how we make our games juicy. So let's jump into what rigid bodies are. All right. So a rigid body is any object that has a rigid body component attached to it. It basically allows physics to affect the game object in your scene as it would behave normally within the real world. So things like gravity or any kind of outside force or torque applied to our game object. This is what rigid bodies help us do. And I've included a link to the Unity documentation page. It'll go into rigid bodies a little bit more in depth, show you the rigid body component, explain what all the different fields do within this component, an explanation, and just different things you can do with your rigid body. So you can hit that up, go into a little bit more detail there. All right, let's go back to our slides. I want to go over what kinematic versus non-kinematic is. If a rigid body object is kinematic, it will not be affected by the physics engine and outside forces. It will only be manipulated or controlled by its transforms. So our transforms, let me go ahead and bring up a scene. And I'll bring up the physics material scene here. And why don't we just zoom in to our ball over our plane here. So our transforms are basically our X, Y, Z's, and our rotation, position, and scale, rather. So kinematic means that only directly affecting these values will change them. Why don't I go ahead and add a rigid body to the sphere, and I'll show you how we do that. Physics, rigid body. I'll expand that. And here we have a few options that you saw a second ago. Is kinematic is checked off. Gravity is checked on. Let's press play and see what happens to our ball. Boom, gravity takes over and the ball falls to the ground. If we check kinematic, our ball does not move at all because the forces of gravity that we have checked here do not apply to this ball. So why have a kinematic button at all? If you apply the rigid body, don't you want physics to take over on your object? I mean, why would you not want if you're going to add a rigid body? Well, like in previous assignments, we use our rigid body component to, maybe move our player, as seen by this code right here. And I can bring up here, you know, rigid body dot transform dot position new vector 3, all that good stuff. It's how we moved our ship in our space shooter last game. So rigid body allowed us to directly access our position and our transform position. But what if you had a character in a game that was being animated, his joints were being animated traditionally, then we would have, their transforms being rotated and moved like any kind of normal character would be animated by. What happens whenever he gets hit by an object like a train or a car or an explosion? Well, then we could uncheck our kinematic property on our sphere, uncheck it, and then all the forces of gravity and physics and the force of the explosion would start affecting his limbs, and we get the famous ragdoll effect. So being able to switch between kinematic and non-kinematic is pretty useful in certain situations. Again, we can add forces to our rigid bodies outside of our typical gravity setting with the add force function here that we can see in action, and the add torque. All right, what's the difference between these two? Rigid body add torque, add force. Well, add force adds a directional force that propels it from X to Z. Add torque adds a rotational force that makes it rotate maybe in the X axis, an outside force that rotates our sphere, for instance. So these are two common ways in which we affect our rigid bodies. All right, physics materials. This is going to be a pretty important part of our breakout game in that it's going to control the way our ball bounces around our level. So why don't we set that up real quick? I called it materials because the way they are made and function act a lot like applying a texture material to something. But instead of coding an object in color, we're going to code it in, a bounciness layer. So the way we do this is we're going to expand our collider components on both our plane and our sphere. And we can see that there's a material value here and no physic material present. Well, how do we make a physic material? Well, in much the same way like we make any kind of material we've worked with before, we're going to right click in our empty field here. We're going to go to create, and we're going to create a physic material. I want to call this bouncy. Okay, and we have a few fields here right now. Dynamic friction means how much force it'll take for a moving object to come to a stop. Static friction dictates if something is already stopped and has zero motion, how much force is it going to take before it starts moving again. But bouncy is what we want to look at real quickly. Let's add a bounciness of, okay, well, we can only add 1. This value is normalized, meaning you can only add from 0 to 1. 0 meaning no bounciness at all, to 1 being it bounces forever. So if you add something like 0.7, it'll be a little bouncy, but eventually it will come to rest. So now that we have our material made, why don't I select my plane and maybe select my sphere? Well, I can't do that. I guess I'm going to have to add them one at a time. So I'll select my plane, and I'll drag and drop my bouncy right into the collider material. And I'll do the same for my sphere. I'll make sure that in the rigid body I have gravity turned on. And let's see what happens to our ball now. Now we have a ball bounce animation without any of the hassle of hand animating that property. And we can increase our bounciness to 1, and we'll have a ball that bounces forever. All right. Or we can take our bounciness to like 0.06. It barely had any bounce back when it landed, if at all. And we can just play around with this value, maybe 0.3. But it's more like a, and there we see it's like a really heavy object. with a low bounciness. And this will be how we apply our bouncy feel to the walls and bricks and the paddle of our level. So moving right along to the basic principles of our lesson here. Let's go over math clamp real quickly. And I'm going to show us an example of how we can set a clamp up. Basically, this just limits the value of a certain float between a maximum and minimum. And I challenged you guys to use that last class, so hopefully you've been exposed to it and understood it. But I'm going to quickly show you how we can set that up real quick. I'm going to bring that over here. Let's open up my math clamp example. And what we have right now is a sphere. We need to add not an effect, we need to add a rigid body to it. Let's turn off gravity. Let's make it kinematic. Because I have a ball mover script, the same kind of script that we've been using to move our objects since the beginning of programming 113. Let me go to my ball mover script. So this is all kind of review right now. We have vector 3s that describe our x, y, and z positions. We have a speed. This is something new to Unity 5 right here. Instead of our rigid bodies just always being stored in memory, we have to initialize and declare a local variable for our rigid body component stored over here in our inspector. So here's just our rigid body, local rigid body variable right here. We got an x position that we'll need to update. So we access our rigid body. We look at the transforms. We want to adjust the position of our transform. And we want to adjust it in the x-axis. So we look at our initial value here. And then we add our get axis input in the horizontal direction, which is just A and D on the keyboard. And then we multiply that by speed. So now we have a new x position value within this frame of the update. And then we need to update our player position vector variable here. So we do our new player position is a new vector 3 coordinate, which is our x position that we just calculated right here. And since we're not moving in the x and y, we leave that 0. And then we take our rigid body transform and we set it equal to our new player position. And this is what actually moves our player here. But something happens whenever we add our ball mover script here. And I'll set this down to 0.2 speed. Well, notice that my ball flies off the screen. Not very user-friendly here. So we need to use a clamp value to keep this ball on our screen. So let's set that up real quick. All right. So I'm going to first make some new variables. Public float x min, public float x max. These two variables will hold the minimum values and the maximum values that can move left and right on the screen. And here's where the magic happens. Let's say that I'm going to make a comment here, new vector 3, and we need to have a position for the x, the y, and the z values here. That's just going to kind of help us remember what values our vector 3 takes. And I'm not going to mess with my y and z, so I'm going to kind of move it over here. But I do need to mess with this x position right here. So I'm going to do new vector 3, and then I'm going to type in math clamp, because my x value right here is what I want to clamp. And it's already asking me, okay, it takes 3 arguments here. It takes what value I want to clamp, the minimum value that it's going to be able to move to, and the maximum value. So I want to clamp my x position. So I'll make a new parentheses, keep note of the parentheses here, x pos, comma, x min for my minimum x value, x max for the maximum value I can go to. And I'll close that parentheses off right here, and I'll bring these over. And now we've created a nice clamp for our x movement here. So this whole highlighted blue part right here is our x value and our new vector 3 coordinate variable that we've made. So now whenever we update our rigid transform position, it will only be within our X min and X max. So I'm going to hit Control S to save. And you'll notice I have some new variables in my ball mover script over here on the left. So I have an X min and an X max. I'm just going to go in my scene view and physically move my ball and see where I wind up with, negative 8.4. Okay, so I'm going to, for my X min, I'm going to write negative 8.4. And since my ball was in the middle of the screen, I think it's pretty safe to say that positive 8.4 or thereabouts will be the max. And I'm just basically moving my ball in the scene view, and I have my game view visible here so I can see the boundaries of which my camera is able to render. So now when I got my new value set here, I'll reset the position of my ball. And now, no matter how hard I fly to the left or right, I'm clamped within my scene. And you can use MathF clamp for any kind of value that you want to control. It doesn't just have to be according to position. In this case, it is. But this whole equation here just says this one value, x pos, is going to be, can only be between this minimum and this maximum. So that's how math clamp works in a nutshell. All right, so here's the big heavy-hitting topic of the lesson here, singletons. In a second, after we get done with this lecture, you're going to be directed to a new tutorial on the Unity website in which they show you
script call
how to make the breakout game in question here. I have it linked inside of our
along with our
module here. You'll see it right below the video I'm recording now.
I'm sorry.
And in it, they introduced this new concept of a singleton game manager.
The coordinates.
Basically, that means we're going to make a class, a single script that controls pretty much all the functionality within our game, with a few exceptions. Meaning, we're going to have access to global variables like our lives, or how many bricks are left on the screen. We're going to have access to global functions such as destroying an object and adding to our score. So that's a little bit, what am I talking about right now? So let's just get into some examples real quick. So what is a singleton? First of all, it's a design pattern or a way we program something that restricts the instantiation of a script or a class to one object. Meaning, we want a single game object, such as a game manager script in our scene, but we only want one game manager, because we don't want to have two game managers out there with possibly different scores being held within their global values. So our singleton ensures we only have one game manager working within our scene. So what can they do? Well, I might have mentioned it earlier, but the common use of the singleton pattern is setting up global variables and functions. These global variables and functions can be accessed in any script without the hassle of doing a get component or find object with name. We don't have to make any more local variables. We can just outright access our singleton class with one easy line of code, get whatever function we need to, take whatever value we need to access, and it's just a really streamlined way to hold global values of data within our games. So how do I make it? Well, before I get into this line of code, why don't I show us an example, a little practical example of how a singleton can make our life easier. So I'm going to go ahead and open up a new scene. I'll go ahead and save this. And in this scene, I just have a ball that will move left to right and destroy cubes. And each ball will increase my score by 1. I'm going to go ahead and minimize some of these components here. All right, so keep an eye on my score. I have a script for stats that track the score of my player, or I've used that same score stat script to assign a score value to each one of these cubes. So each cube in my scene is worth 1 point, and on my ball is where I'm going to keep track of my score. So as I press play, I'm going to, maybe I need to actually add the X-min and X-max to the scene here. So I need to update my ball mover script like so. So my X-min will be negative 8.5, 8.5 for my max, and now I won't be confined to the middle of the screen anymore. And I'm going to unmaximize so we can keep an eye on our score here. So I move, hit 1 cube, that's 1 point, 2 points, 3 points, 4 points, 5 points. So after I destroy all the cubes on the screen, I get a score of 5. And basically, I'm just working with a hit script that detects collision. So anytime we've seen this on collision enter, basically I have to create some local variables here in which I make a new local variable called other stats. That way we can get at the stats of the other object we're colliding into. And then I make a this stats that can get at the stats of the sphere that of the ball that's actually moving and hitting things. So here are our two local variables so we can access our stat script that you can see here. And then I destroy the object I run into. So I destroy the other game object. And here I update my score. I say this stats dot score, meaning the score on this object that our hit script is attached to equals the score plus the other stats score value, which is 1. So that's basically how we're doing this. We're just moving our ball. We're having a on void collision script, and it's destroying the other object we collide with, as well as increasing our score of our ball by 1. So you'll notice that I also have a new value called multiplier on our stat script. And what happens if maybe we hit 3 cubes and we get a score multiplier in which we got a kill streak going on. Now everything we kill is going to have a score multiplied by 2, so we start racking up more points the better we're doing in the game. Pretty common thing in most games. So let's do a few things here. Let's say that the first 3 cubes are worth 1 point. Cube 3, which is the 4th cube, confusing, yes. Maybe we'll keep it at 1 point. We'll just keep everything at 1 point. But by the time we kill 3 cubes, I want the score of each cube to be multiplied by double. So we hit 1 cube, 2 cubes, 3 cubes, then we get a score multiplier. Well, you can see that I have a multiplier script on our multiplier value on our stat script. So there's a problem here. We can, what we have here are 5 cubes with 5 instances of my stat script. And what we can actually do is every cube is worth more points than the last. So let's say cube 2 is worth 2 points, cube 3 is worth 3 points, cube 4 is worth 4 points, and 5 is 5. So we have our ball with no points because it hasn't racked up any points yet. Our first cube is worth 1 point, and then each cube after that is worth more points. Well, that kind of seems like a multiplier, right? But I'm just pointing out the fact that all these instances of our stat script can have different values assigned to them. And we've already seen that in previous lessons in which we use like a global stat script to control things, values for the missiles and bullets and asteroids that we've used. So by the end of it, I have 15 points. Well, there's a problem because if each stat script is its own instance, has its own values, well, are we going to have to change the multiplier for everything in the scene as soon as we rack it up? Because if I just change the multiplier on this cube right here, the 4th cube in the scene, why don't I just do this? A little bit more. So cube 3, not the 4th cube, we'll just start calling it cube 3. If I want, by the time I kill it, I want the multiplier to double my points, that means I'll have to go and check cube 4 and also update its multiplier. That just seems like a pain in the ass. What if multiplier could be a global value that we just update once and it sets the multiplier for every cube in our scene? That way, we don't have to go to each cube, make an array that makes a list of each cube in our scene and updates the multiply value through a for loop. Can you imagine the amount of code it would take to create a list of all these cubes and update the multiplier one by one? It's not very convenient. It takes too much code, too much time. Well, how can we do that? Well, we'll get into singletons, but we really need to understand what static variables are. So if we go to my stat script, what if I made a public static variable for my multiplier and hit Control S? All right. So a few things, something noticeable happens. I no longer see multiplier in my inspector. Basically, my multiplier is now global, meaning it affects all of these cubes. So it wouldn't make sense to show it as a single value represented in my inspector since it affects all of my cubes now. All right. So I need to create some logic here on my hit. Let's say we need to track how many cubes I've hit. So why don't I make a new variable, say public float number destroyed. And in my hit, I'll say if this stats dot number destroyed is less than 3, then we're going to do just a normal plus other score. Else if this stats dot not broadcast message dot number destroyed is greater or equal to, actually I did that wrong. This stats less than 3 is equal to or greater than 3 here, meaning we've already killed 3. Let's see, this would count towards, yeah, we would be counting from 0. So 0, 1, 2 would be the first 3 cubes, so we would just do a simple plus score. But yet, else if the number destroyed is equal to or greater than 3, we want to do something else. We want to basically add that multiplier to our score system. So we do this stats score plus other stats times other stats dot score times our multiplier, which would be, yeah, just other stats dot multiplier, right? And that should work. But we get a purple because, I mean, we want to access our multiplier and multiply the other stat score. Let's see what kind of error we get here. Well, first of all, I don't know how to make conditional statements anymore. All right, so the stat does not contain a definition of multiplier. Stats can be found. What is going on? We're not getting. Well, in this case, since our stats is now containing a public static multiplier, we just have to do simple stats dot multiplier. So a few things here are different, right? We actually don't need to use the local variable that we described right here, or initialized and declared right here. We can just outright access our stats script, and then we want to get at the multiplier there. So we don't have to declare local variables to get at our multiplier. We can just access the script outright. So that's pretty cool for our static variables right now. Let's see what happens. All right. Hopefully my game logic works. Let's select my ball. So We'll see by the time we hit cube 3, our score should be worth double, so that should be 8 points. And this should be worth 10 points. So remember, by the end of the last go around, we had a score of 15. So we have 1, 3, 6. So if this should work, we should be getting 8 points. It's not working. Let's see what we can do with our logic to get this to work right. I think we left one important piece of code out here. We forgot to increase number destroyed by 1 every time we destroyed something. This stats number number destroyed plus plus. And we'll add that same line of code. Actually, we can add it at the end here. Let's see if that works. We'll keep an eye on the number destroyed as we go through. Destroyed 1, we destroyed 2, we destroyed 3. Now, we destroyed 5, but it didn't update our score like it should have. I wonder why that is. Well, right now, our multiplier is initialized to 0. So what we need to do, why don't we go ahead and give our multiplier a value of 1 here. All right. So I think there's a way to simplify this. So if we have a multiplier of 1 starting out, we can use this line of code constantly. So we can just say, we can just outright use this multiplier. Because if we're multiplying by 1, then other stat score will just stay what it is. But what if we just said something like, if number destroyed is greater than or equal to 3, then stats.multiplier plus plus will increase our multiplier by 1. So our multiplier will be 2 now. So now we should have the logic that will work for us. All right, great. All right, number destroyed is 1, 2, 3. Boom. And there we have a new score of 20. But let's see. Maybe we need to do something like, I see what's happened here. We didn't get what we wanted. It didn't start in the multiplier until after we destroyed the third object. So why don't we do this if check before we do any score calculations? All right. So after we destroy the object, why don't we, so this is just a nice little exercise in how the logic of the order of your logic will affect your code. So basically what I had to do is I had to destroy the other game object. So I wanted to trigger, I've destroyed one object. All right, I've increased my number destroyed by 1. Now I'm going to do a check to see if the number I've destroyed is greater than or equal to 3. And if so, I'm going to increase my global stats multiplier by 1. And then I'm going to adjust my score. So maybe this will work now. Score 1. I've got 3 points. Boom. 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 And there you have it. All right. Let's see if this is what we wanted. Why don't we just set all the scores back to 1? So all the cubes are now worth 1 point. Now we can check our math a little bit more. We've killed 1. We've killed 2. Let me select my ball again. So we destroyed 1. We destroyed 2. Well, what's going on here? Still not getting what we want here. What do you think the problem is? It's got to be with the way I'm testing. Well, why don't we just do if as soon as we've destroyed 3 objects, then we'll increase the multiplier. Maybe we don't need a less than or greater than sign. Okay, destroyed 1, get 1 point, 3 points. Well, now our score, we just got double. What gives here? Again, we need to do some logic reordering. I need to check right after I destroy it if the number destroyed equals 3. And then I need to do a destroyed plus plus. Ugh. Just trying things out. Do a score of 3. Then we get a score of 5. And then of 7. We got the multiplier after we got that. And what might have helped is if we did a debug.log and then score multiplied within our console. That way we can see exactly when we were getting our multiplier. And then we should see in our console score multiplied. Boom. And that way we know exactly when we're getting it. Okay. So that is how we can use public static variables to control global values within our scene. So instead of having to set the multiplier of each one of these cubes individually, we just used a static float. So if we go back to the notes here, we can see how we can make a Singleton game manager. And why don't we go ahead and set that up for this scene right now? All right. So you can I have this right here. Maybe I'll leave it up and we can maybe fit both of them on the screen. I don't know. We'll try it. All right. So I need to make a new C#, and we'll call this Game Manager. And then within my scene, I'll create an empty Game Manager. Call this empty game object. I'll call this Game Manager. And I'll reset its values. And I'll attach my newly made Game Manager script on my Game Manager. And why don't we open this up? All right, so let's reorganize some of the code here. First of all, I'm going to take this multiplier and plug it into the values of into the script, my Game Manager script. We're just going to create a nice global variable here. All right, and I'm going to reorganize some of this code here to make it more visible. So before we really get carried away with making new variables, let's do a few things here. We got to set up our Singleton class. So what we really need to do is we need to write some code here and make sure there's only one game manager in our scene and that we can access the script with only one line of code. Kind of like how we accessed our multiplier with just this simple line of code right here. So what we're going to do is our class is called Game Manager. We're going to create a variable as seen right here called instance that points at our Game Manager script. But that's weird. Instance lives inside of Game Manager. We're going to create a variable that points at the class it lives in. Well, that'll be helpful because it's going to be public static. So we'll be able to access that instance anywhere within our scene. So let's do that real quick. So I'm going to say public static of type Game Manager. This is the script I'm working in, as we can see here. And then I'm going to call this variable instance. And I'm going to set it equal to nothing, to null. So right now, I've basically declared a new variable that's a global static variable of type Game Manager. But it's not equal to anything yet, meaning it's not equal to this class that we want to set it to. When we're going to set it to the class, our game manager class is within start right here. So I'm going to go if instance equals null. That means if our variable that we just declared right here equals null, meaning it is not set to anything, then we want to declare it as something. We want to give it a value. And we want it to point at the script that it lives in, our game manager script we're working in. So we just say instance equals this. Now this is a new one for you. This right here. Not this, but this syntax is new to you. Basically, this points at whatever script it's written in. So this is pointing at our, let me get rid of these other, I'll save that. This points at our game manager script. So basically what we're saying is if instance is not equal to anything, no game manager in the whole game or in your whole scene, then we're going to set it to this. We're going to set it equal to the script that we're living in. But then we want to make sure there's only one instance of our game manager within our scene. So we'll do else if instance. Remember, instance is the name of our game manager variable that we've declared up here, or initialized rather. And if it's equal to nothing, if it's not equal to anything, meaning instance does have a value, we're going to destroy whatever game object we're attached to. Okay, there's a lot of weird stuff going on right now. Let me get rid of this multiplier so I can just simplify it up a little bit. So what we have right now is a game manager. I want to ignore these error codes for right now. That's because I got rid of the multiplier variable. What we have right now is a game object. Okay, we've called it game manager. It's just an empty game object within our scene. We've attached a script called game manager, as we can see here in our inspector. So we have a game object with our game manager script attached to it. We've declared, or we've initialized a new variable called instance of type game manager, of type this class that we're working in, the script that we're working in, and we've made it a public static, meaning our variable can be accessed within anywhere within our scene, within our game. So we can access it really easily. We don't have to do a get component or a local variable inside of another script, because we can bypass this mumbo jumbo right here. And granted, this won't do away totally with this programming technique, but in this case, with a game manager, it will. It'll make life a little bit easier. So this line of code just basically initializes a new variable of type game manager. And what we do in start, this is where we check to make sure there's only one instance of our game manager in our scene. Okay, maybe something weird happens down along the way when our games get more complicated and another game manager tries to get made. This line of code prohibits that from happening. Basically, it says if instance doesn't equal anything, then we want to set our instance variable to our game manager and our inspector. But if our global instance within our scene already equals something, meaning it does not equal nothing, then we're going to destroy the game object it's attached to. Basically, this means that if two game objects exist in our scene, our new game object that we just duplicated, boom, gets deleted, gets destroyed. And that's exactly what we want. So now we've just made a Singleton class that we can access from anywhere within our scene. So let's go back and make our multiplier variable. Wait, you know what? We don't have to make this static anymore. We can just call this a public float multiplier. And we're going to declare that as 1. So now we can access my multiplier through my game manager. So if I go to hit, instead of doing stats.multiplier, I'm going to go to game manager dot instance dot multiplier. And there we go. So it's a little bit different. Instead of just doing something like before it was just stats.multiplier, right? Well, that's because in our stats, let me bring up stats again. In stats, we had multiplier already set to a public static float. All right, I'm just going to comment that out because we don't want the multiplier there. But here, we've already taken care of the public static by declaring this variable right here. So anytime we want to get at my multiplier and my game manager now, we're going to use the type game manager, the variable that we created right here called instance, and then we can get at the multiplier variable right here. So if I hit Control S, I think stats does not contain a definition for multiplier. That's in our hit. And there we have to update this again. So game manager dot instance equals multiplier. So here we have our singleton going to work for us. We have our game manager type, our variable name, and the actual variable inside of our script right here. So might be a little confusing, but it's how it works. I'm trying to explain it as simply as I can. I know when you talk about code, sometimes you can talk yourself into circles, it feels like. So if we hit Control S, and now let's keep an eye on the ball. Boom, boom, boom. Now we should get our multiplier, and now our game is working just like it used to. But we've created a game manager to handle the multiplier, like so. So here we have in our notes right here a basic legend, and you can look through this again. This is just exactly what I programmed, and here we have how do I use it. It's just what I did with the hit right here. This is how we use it. We called up the class that it existed in, and then we call up the variable that points at the class, and then we actually call up the value that we want to get at. A little bit confusing, but think of it like this. This is the type, like maybe like the stats here, how we call the local variable. This is the pointer. This is what points. What game manager type are we trying to look at? Well, this is the pointer that points back to this. And then what's the actual thing we want to get at within the pointed to game manager, which is our public float multiplier right there. Okay? In fact, we can see our multiplier get updated within the game now. If you look over here, this is actually our game manager highlighted, and now we can see multiplier in our inspector. And boom, our multiplier gets bumped up to 2, and our ball now has a score of 7 instead of 5. And that's really the basis of the singleton. But what if I told you you could call functions you make in the game manager this way too? I don't even know what's going. How do you do that? Well, what if in our game manager we made a function void score update? What if we made a function that handled the updating of our score? What would we do here? Well, maybe we could do something like, why don't I take this and the actual updating of the score could be done here, but we're getting a whole lot of red here. Well, maybe we need to declare some values to be passed into our function here. This score float other score. This score equals this score plus other score times that, and we're actually going to return this score back. So what have I just done? Why don't we do something like game or this stats dot score equals my game manager dot instance dot score update. I think that's what I called it. And we need to pass in some values. Let's see. How did I do it? We need to pass in this score, so we have this stats dot score and other stats dot score. What is wrong here? Accessible due to its protection level. So I need to go back to my game manager and the score update function I'm making. I need to make it public because it wasn't it was a private function. If you don't describe something as public, it'll automatically assume it's private, meaning it can only be seen in the script we're working in. Public means I can access it anywhere. So there we go. So now anytime I want to update my score, this stats.score will equal, and then I'm going to call my game manager.instance, but instead of going to just accessing the multiplier, I'm going to call the score update function that handles all the math for my score, but I need to pass in two values. I need to pass in the score value of how many points I have currently as a player, and I need to pass in how many points the other object is worth. And so that's why I have a this score and other score here. And then I return the score after the math. Let's see if that works. Boom. So there we have some pretty heady stuff going on. We have our hit script assigning the value of the stats on this game object, as we can see right here. It's assigning it to, and then it's calling a function in my game manager. It's calling my score update function. It's passing values from my stat script of both the player object and the other object I'm colliding with. And this function is returning the score after we do all the math with the multiplier here. That's a mouthful, right? Well, that's just a basic introduction to what our singletons are doing whenever you see the lecturer talk about them.
On the X, just going to have equals no. So we're going to unparent the ball from
within
the package to
the
when we
next
create a folder
tutorial you'll be watching.
available. This is
And
something
here
that
he
I
is
kind of
making the
struggled
game
with when I
manager
first started
class.
learning Unity, and
There's
I
that public
think even though
static
it's a little
variable
bit of a
right
more
there.
advanced concept,
And so you're not kind of like, well, what's going on here? There you go. That's singletons in a nutshell. It just makes use of that public static variable. And the hardest thing to wrap your head around is we we make a variable that references the class that it exists in, so we can use it freely, like so, in other scripts. All right, so that's singletons. Hopefully, whenever you start making your game, you'll see how they can be really helpful. I mean, by the end of it, I think they were like, I'll go ahead and bring up the game manager over here. So this is the game manager you're going to be making in the tutorial. We have 1 function, 2 functions, 3 functions, 4 functions, a check game over function, a setup function, an awake right there, and then we have all these public variables right here. They're going to be able to be accessed in all the different kinds of dead zone bricks, ball scripts. So you guys are going to be really exposed to singletons in a big way, but hopefully by the time you're done with it, it'll all make sense. So lastly, for our lecture, I'm going to introduce you to what juicy games are. And we're just quickly going to watch this about a 14-minute presentation of some game developers here. You can see them credited right here. And they're going to talk about what makes something juicy or not juicy. And I am going to take a step back. You guys are going to just be able to watch this.
You are too kind.
I'm not sure. Last time we did, everyone was standing up. So
Yeah, we'll get them eventually. So we're going to talk about how to make your game juicy. And I guess it's kind of like whimsy. It's this abstract notion of something that you need to have in your game. And I'm going to start by telling you what juice exactly is. In video games, juicy things are things that wobble, squirt, bounce around, or make little cute noises. It's sort of a catch-all phrase for things that make the game feel good to interact with. The term juicy comes from this classic Gamma Sutra article called How to Prototype a Game in Under 7 Days. And they say this: a juicy game feels alive and responds to everything you do. Tons of cascading action and response for minimal user input. And use is typically visual or auditory, but it doesn't really need to be. Emily Shorts mentions on her blog that interactive fiction, which is a text-based game, they can't really do wiggles and squirts much, but they have their own kind of juice, the fun and sort of unexpected responses you get when you try something in the game that you're not supposed to do. And that's pretty much what juice is about. It's about...
All right, so that's what juiciness is. It's basically adding pops and bells and whistles and fun things to your game. I'm going to link this video within our module here so you can watch it on your own. And what you're going to do after you create your basic breakout game is you're going to add 2 features to make your breakout game juicy as well. So anything like sounds, screen shake, maybe adding a power up that adds another ball, maybe more art assets that, I don't know, spice up the game. I remember you see in the video that he'll add like a little face that gets sad when the ball gets further away. Just anything that adds visual interest and something that captivates the audience or your player a little bit more. So that'll do it for this lecture. Right now, I want you guys to either watch the Juicy video first, or if you want to go ahead and get building your game, you can watch the live training video that you found on Unity on the module right here, made by Unity themselves. And right below it, I'll have the Juicy video linked, and you guys can, hash out things yourself. So either build your game first or watch all the juicy stuff first. I think either way, you'll be fun. To make the game juicy, to have the features like that, you guys are going to be on your own here. I want you to be able to go on the internet, see how you implement sound, see how you implement screen shake, see how you can figure out a way to maybe once all the half the blocks are gone, another ball spawns randomly in the level, and you have the ability to use 2 balls to kill all the bricks, or maybe whenever the ball hits the water, maybe make a splash effect, or maybe change the color of the walls anytime the ball hits the wall or something. So it's constantly changing color every time the ball hits something. These are all functions, and this is all kind of functionality that I know you guys you have the tools to do. It's just maybe you'll have to look up some resources like, okay, if I want to change the colors, how do I access the color material value? You know, how do I get, if the walls are red, how do I get at this value, this albedo color value, and how do I change it to blue every time it hits, and then change it to purple, or how do I get at? This is just another. This is just another component on, say, something like the wall left. It's just another component, say, like getting at the transform position, but now instead you're just getting at the material itself. So with a little bit of research, and definitely ask me for help. Email me if you need to. You guys can add some pretty interesting twists and turns on the breakout. Basically, I just don't want a carbon copy paste of the video from the Unity live training session right here. You guys are going to have to add at least 2 juicy features to the game. So like I said, let me go over the fact that this will be due in 2 weeks. So you have 2 weeks to make the base Unity game, and then to also add 2 features that add the flair to the game that you'll watch in that video. It's pretty good way to think about designing your games, because Breakout's kind of a boring game if you get down to it, but when you add all the juicy flair to it, it can be pretty fun to experience for your player. All right, like I said, if you have any questions on singletons, or how exactly you're struggling on what kind of things you can do to make your game juicier, please email me. Again, you only have 2 weeks, so you may want to get started on at least building your game. All right, thanks guys, and good luck.